Hi, everyone. I hope everybody is able to hear me. I'm going to go ahead and present how you optimize your apps with the new concept called as app bundle. So when you actually do this, you basically will have a couple of advantages. One of them being that your app size reduces quite drastically. Second one is that you can serve things dynamically. And I'll go through each of these steps and how you might want to use these things in order to help improve your apps. So moving on, my name is Amrit Sanjeev. I'm a senior developer advocate at Google, and I manage developer partnerships in India. Mostly, my work is to work with large partners in India and help them build on Google technologies better and take some of that feedback from them and use it to kind of improve some of the Google products. So in this session, what I'm going to talk about is what is the app bundle format in itself? What are the advantages going down and using app bundles? Google Play signing. I'll touch upon a bit of that also. And developer tools that you might want to use to help uh, build the system really well. And lastly, I'll touch upon dynamic features, which is a pretty interesting new concept that we've added to Play this year, which will allow you to dynamically install modules on the fly based on users' preferences and things like that. So let me quickly move on. What is App Bundle? App Bundle is a new publishing format that we have added to Play, where this is not an installable by any means. Installable is still the APK. You have a new publishing format. So instead of uploading an APK to Play Store, you are now going to upload a new file format called as AAB. Now, what it contains, how is it different from an APK? Well, it contains some additional metadata which we can use in order to generation of APKs on Play servers. It also is a slightly more stricter format to APK, and this strictness is basically because you basically want tools to perform a lot better. So in order to ensure the integrity working with tools, we have added it to be a slightly more stricter format. Now, if you look at the internals of this thing, it's very similar to how you would look at if you disassemble an APK and see, it's very similar to that format. Every module in an AAB contains a manifest, dex, resources, all these general files, which contains the dex files, the resources, the drawables, values, all those things, assets. One of the major differences that you would see is that when you look at the resources.pb, assets.pb, and native.pb, these are three files which are lookup tables for one for resources, the second one is for assets, and the third one is for native SO files. These are in protocol buffer format. And the reason for keeping them in protocol buffer format is that they can be easily transformed by the tools that we have. Secondly, it also contains some additional targeting information also. So that is one of the major changes if you can take a look at an AAB versus an APK. Now, when you and one more thing why we did not change the APK formats, change the AAB format completely to be a new format from AAB from APK is basically because we didn't want too many changes to the tools that were working with APK earlier. We wanted them to be able to work with AAB also easily. So that's why the formats were not changed much and were kept as close to each other as possible. So moving on, the core concept of this whole AAB format is that you have a concept of dynamic file delivery. So in a nutshell, in one line, if you want to understand that, is basically you are serving only files and assets to which the device would use to that device for that user. So SO files, which are of different architecture formats, which never would get used even if you serve to the device, will not be served in this case. Now, app bundle reuses the targeting information to generate an APK which contains the right resources, the right architecture files, then the right language support. So by making the APKs have only the files that on that device will ever get used, you are completely reducing the size of the APK. We are also going to add texture compression format later this year. At the moment, we are not we are not removing files which are from based on texture format, but that's something that we are going to add later in future. Now, to explain this a little more, when you look at resources, let me add on to the next page. So how does this get served? So there's a concept called a split APKs that we introduced in L, which is the same format as a normal APK, and but each split APK can be installed separately, adding to the main APK. So you might install a portion, like in this case, if you take an app bundle, the app bundle gets split into the base APK and base split, and if you the all the ones in orange are basically the density splits. So there is a split per density. Then there is a split, the yellow ones, the splits per the architecture, and then the splits per the language. Now imagine that you have a device which is of a particular configuration. You would then choose the base plus the appropriate splits that you need for running the application on that device and ignore the splits which are not required. And that's why the size of the APK is much smaller. Now, showing an example here, we have a Samsung Galaxy J5. Now, which whose configuration is basically it has English selected as a language. It is an ARM processor with an XHDPI display. Now, when the user requests for an APK, the base APK is taken, then the XHDPI split is taken, the ARM split is taken, and the EN split is taken. Only the ones that I've highlighted here in dark orange, dark yellow, and green and blue are taken together, and the rest of the splits are not actually used, because only this is required to let the application fully function on that particular device configuration. And this is taken, a new APK is generated, signed, and sent to the device. Now, because this contains only the splits that it requires, the size is drastically reduced. Some of the apps are saving up to 50% in their APK size by removing some of the unnecessary components for that particular device. Now, this is done automatically by Play, and you don't have to do any configuration for this. All you got to provide is an AAB to Play. Now, in case configuration changes, like you've selected a new language on the device as an additional second language on the device, let's say it's French, for example. What happens in that case is that on the fly, the Play Store app will understand that the user has changed the configuration on the device and would automatically download the French split and install for all applications on that device, which are configured with AAB. That means you can dynamically update the app based on users' configurations on the device. And you don't need to code for this. This automatically happens under the hood. Now, I talked about this as a feature that was introduced in L. Now, when you look at this, what happens to devices that are pre-L, before L? In such cases where the split APK is as a concept is not supported on the device, what we do is we generate a matrix of individual APKs, which are a combination of a density and an architecture. We are not using languages to create the array of APKs, because that will create too many APKs. So in this case, we create from the app bundle, we create a matrix of APKs as shown here. And this is very similar to how multi-APK worked, where if you were using multi-APK for your apps, this is exactly how they worked in the past. Now, from this split, based on when the user is asking for information, based on what is the configuration of the device, the most appropriate APK out of this matrix is served to any pre-L device. Now, this whole change where before L, it has to actually send it from the matrix. After L, it is, or L and above, it basically creates the APK from the splits and sends out the new APK, is all hidden under the hood in the Play server. So from as a developer's perspective, when you look at it, all you got to do is to upload one file, which is the AAB instead of APK to the Play, and all this magic happens under the hood, and the most appropriate optimized version of your APK is then served to the device based on the configuration of the device that is requesting, and that happens automatically under the hood, and that improves size savings, makes your apps get downloaded a lot faster, the install friction reduces for the user, and things are all better in this case. Now, what are the new things that are coming? One of the things that we're looking for is to do it based on graphics APIs or platform features and graphics API. So this will again help improve the size in terms of in cases where you have a lot of gaming applications, for example. In gaming applications, the graphics texture splits would actually allow a lot of size savings for additional secondary downloads that happen on the device. Now, how do you actually go ahead and implement this? Now, if you're using the 3.2 canary onwards, we have an additional head under the build APK where you would actually have under build menu, you had a section called build APK. Now we've changed that to build bundle or APK. What you got to select in this option is bundle, and the rest of the process is exactly how you would do for an APK, where you would sign with the key store. The same screens are then will come up, and the output of this process would be an AAB file rather than an APK file, and that's as simple as that. You don't really have to do a new process for this. It's built into Android Studio from 3.2 Canary onwards. It's available under the build menu. Now, there is also some of the developers have been asking us questions like, what happens if I want to generate uh, an APK, which is either a universal APK, which contains everything, like I'm generating it today, or what if I don't want the splits based on architecture language? Now, inside the Gradle block, Gradle to inside the Gradle of your app, you can actually have a new bundle block, which you can specify which type of splits do you want to allow and which types you want to stop. So by using the enable splits flag and keeping it as a false or true, you would be able to tell Play System that, hey, you need the application to be optimized for density, AAB, language, or any combination of these. Now, you can, for a universal APK, for example, you can then turn all of these flags to off, and that would allow you to kind of make sure that you get the entire APK as you would make entire APK served by Play the same way as you would have been uploading it earlier. So there is no optimization in that case. Now, in case of testing, there are multiple approaches that one could take here. In there is a new track apart from in Play Store. There's a new track apart from Alpha, Beta, and Prod. We have added a new track called Internal Test Track, in which you can add up to 1,000 testers, and when sorry, up to 100 testers can be added to it, and you can upload an AAB and it will immediately reflect that 1 to 2 hours that you might otherwise see as a time gap for getting an APK. When you upload an APK to the point where you can serve to users or testers, that is taken off, and you can actually see it immediately on the device. So the moment you click upload, uh, when a tester would actually search for it, they would actually find the new version in Play immediately. The second way is to use a bundle tool. The first way, you're making Play do all the work. You put a AAB on the Play Store in the internal test track, and your testers will get it by downloading it from Play Test. Some people want it completely offline. In that case, you want to use the bundle tool. The bundle tool basically allows you to create a collection of APKs using a tool locally and then install the right APK on the device. You could also use some scripting along with bundle tool to generate and do it from your continuous integration systems also, in case you are using those. So either of these approaches can be taken. A lot of people are now currently using the internal test track, and some of them who have automation of build are using the build tool, are using the bundle tool to test. Now we have introduced a new tool in Play console called as a bundle explorer. This tool basically allows you to navigate all the uploaded bundles, and then you can see the APKs per device configuration, their size savings, and also the device list. It the image on the right of the screen kind of signifies how it comes. The, the image shows how it comes, where it shows an average size savings. It shows an average size. I'm sorry. It shows an average size savings along with the second portion where you can actually see per configuration what is getting served to each of these devices. You can get the device list. You can get the device list and then see which all devices will get what APK. You can even go ahead and download an APK from this screen. You can go ahead and download the APK from this tool and then test it out. This is a tool within the Play console. Now, when you're using a bundle tool, the bundle tool will generate a set of APKs and then will allow you to install onto a device that is connected onto your computer or to an emulator. Or you can also make it generate an APK by providing it a configuration. Now, in order to do all this, there's one prerequisite that you need to do, which is basically app signing by Google Play. You will have to opt into this one. And I've taken two pictures here in order to explain the Google Play signing. Basically, the one on the left, which is the orange one, is how you were doing it. You are doing it right now. You have your own key store. You create an app. You create an APK. You sign with the key store. You send it to Play Store, and the Play Store would serve that APK down to all your users. Standard format. Now, in Google Play signing, there is a slight change. When you opt in for Google Play signing, you will actually give Google Play a copy of your key store. Google Play will then give you an upload certificate, which is another key store that you will get from Play Store. You can download. And then when you're actually generating an APK, you would sign it with the upload key and then give it to Play. Play would then actually use the private key of this upload certificate to disassemble the AAB that you have given us, pick the appropriate config splits out of that, bundle it into a new APK, sign it with the private key you provided earlier during the initial Google Play signing step, and then serve it to your users. From a user's perspective, there is no change. If an app is already installed on the device, they get an update. If an app is not installed, they get a fresh install. From a user's perspective, there is no change. The only change is that instead of signing with your key store, you're signing with the upload certificate and then sending it to Play Store. Play Store will then, on your behalf, sign the APK and then send it to the user. So users will automatically get an upgrade even if the first version they had on the device was signed by you, and second one, and once you move into Google Play signing, uh, once you move on to Google Play signing, after Google Play signs your APK, they will still get an upgrade. So this is a straightforward process that you will have to do as a prerequisite before actually going to AAB format. Now, what are the advantages that you're seeing based on this format? One is immediate size saving. Without any code change, you're going to see a substantial size saving in most apps. That is because there is, like I said, the unnecessary resources are not served. The unnecessary library files are not there in your APK. The unnecessary languages are not supported in your app. Now that way you're saving some space, and the APK download size actually reduces quite drastically. Second advantage is that you basically are not having to deal with multi APK uploading multiple APKs based on different splits and all that. You don't have to worry about that. Play Store will take care of it. All you got to do is upload one app AAB format file to play. So instead of uploading 5 of these APKs for every version, when you're doing multi APK model, you just upload one AAB file right now. Thirdly, this is based on device configuration. So in case a new configuration of a device comes in, you can be assured that Play will serve an optimized version of this down to the users. So for every new device or every new configuration that comes in, you don't have to worry about having to then go and modify your build process to generate a multi APK split or a multi APK for that particular configuration and things like that. So you are saved on a lot of time in terms of publishing based on this format. Now, I just want to highlight a few of the India partners that have actually gone ahead and did this. Swiggy is a #1 food delivery app in India, and they've seen a size savings of 23%, roughly 23%. And Reify, which is another a recipe app, they've seen a 48% size savings for their app. And Hotstar, which is a media app, has seen up to 18% size average 18% size savings for their app. And you must understand that these apps have not changed a single line of code to get these sort of size reductions. They've just converted the format of upload from APK to AAB to app bundles. Now, the second part of this talk, I want to talk about modularization and dynamic delivery of them. Here, till now, I talked about delivering everything, all the features to the user, and splitting based on your architecture, language, and density. And what we're going to talk about further is now serving only features of your application which are used by users. Now, I'll explain that with an example as we go. But let me explain what modularization is here. By modularization, what I mean is to split your app based on the feature usage. Assume you're an app where somebody can actually write let's say it's like an app for blogging. So somebody can read the post there. Certain users, once they log into the post, you can contact, say, chat with the support team with the app. So there are 3 major buckets of functionality here. Now, when you look at it, most of your users use your app for reading blog posts. Some of your users also write on the app, and only very few are actually using the support channel and talking to your customer care. But in the current model of app development and serving, you have to bundle all these 3 features together and send it to users. This means that users who are not using any of the other two features, are still having to download and keep it on their device. Now, what if you get an opportunity in such a way that when you install the app, you only have the reader coming down to the app? When somebody clicks on a button to write a story, that's when that split or the feature gets downloaded automatically and updates your app, and then the user can actually write a post there. If they go to the section where they want to chat with the support, that is when that feature gets downloaded along with the libraries it requires, along with the UI that it requires, and then continues the flow from there. That's what modularization and dynamic delivery allows you to do. Each module can be installed on the fly based on users' preference or users' interaction with the app, and thereby initially your app is a really small, most used feature list that comes down. Now, if you want to split, how do you modularize and which parts do you want to modularize? Now, you want to kind of figure out which features are only used by a small percentage of users. Now, those are good to be modularized and moved out as a dynamic feature, because That subset of users, when they want to use that feature, will be getting it downloaded from the Play Store directly. The second one are features which take significantly large space on the disk, where that will increase the install friction. You might want to defer that to a later point of time for install, or when the user first wants to use that feature. So they are also good candidates to kind of move further. One thing that you want to note is you don't want to kind of introduce a feature which is part of a workflow. You don't want to kind of introduce something which will then go ahead and break somebody's workflow, where okay, he comes to a screen, clicks on a button, a module gets downloaded, installed, and then he can continue usage. Then the next button he clicks, another module gets downloaded. So you are breaking the flow of the user, and you might have large drop-offs there. So you want to take care of the fact that you don't really split based on uh, split inter workflow things. Now, what will play excuse me, what will play do? Each module will consist of a base split, which contains the base feature that we're talking about. In this case, I have a base split which contains all my resources, all my libraries, and the basic functionality of my app that I want to serve to all my users. There is also a section for add recipe, which is a separate module. There is a section called as VR viewer. There's a section by rather than a section, let me call it a module. A module called as add recipe and a module called as a VR viewer. Now, when a user installs my app, only the base module comes down. After that, when the user is going to go ahead and click on add recipe, that is when the add recipe module gets downloaded to the device, gets installed, and the user can continue from there. If he chooses to use the VR viewer, if he chooses to use the VR viewer module, that is when that module will get served down, and the user will be able to continue using that functionality. Now, if you see, only the base module initially comes, which means a smaller portion of the app comes in, which everybody uses. And depending on who wants to use which feature, those features gets added dynamically onto the device, on that device. Now, pre-L, we have a flag called fused, which has to be turned true or false to add the module to the base feature when it generates a matrix of APIs. Now, in this case, I have called the add recipe module to be true and the VR viewer to be false. Now, pre-L devices do not support VR viewer library, so I've set it to false, which means the matrix of APIs that get generated APKs that gets generated will not have the VR viewer module there. It will only contain the base and the add recipes feature in it. Now, how do you create a dynamic module? There are two ways of doing it. One is, if you have an existing app, you can go ahead and edit some of the files to get to make something a dynamic module. Or in case you are actually starting a new dynamic module in your app, then you can use from Studio to 3.2 Canary onwards. We have introduced a new wizard for dynamic in the new module wizard. There's a dynamic module section where you actually would click on it, just fill the details on your dialogues, the dialog boxes that come in, and the dynamic module will automatically be created. Now, in case you have already have a code and want to convert, there are a couple of things that you got to do. One, in your manifest, you have to add a module tag, give it a title, and set the on-demand flag and the fusing flag. Set them to true or false to indicate to play that, hey, this or indicate to the build system that this is something that has to be uh, served on demand, or for pre-L devices, it has to be included within the APK that is getting generated. Now, in your Gradle files, you got to go to the dynamic modules Gradle file. You got to add a plugin, which I've highlighted in green here, and then add the dependency. Under the dependencies, add a dependency for your base module, because the base module contains all the common libraries and things like that. A base module is always required, so add the dependency for that. In your base modules Gradle file, add a head called dynamic feature and tag in that tag, specify all the dynamic features that are supported by this base module. Now, in case later you're adding a new module, you have to go ahead and update this to accommodate the name of the new module also. Then only that module can be installed on that particular, can work with that base module. Now, how would you really get a new module to install? So for that, we have introduced a new thing called as a PlayCore library, which has an API called a Split Install Manager API. This works with the Play Store app in your device, and then goes to Google Play servers, fetches the modules, and and installs the dynamic modules on the fly. Now, constructing I've highlighted the code required in order to call and install a dynamic module. You initialize the Split Install Manager. You create a request, specify the module that you want to install, and then and then give the trigger to start the install, calling the start install. You can add a success listener or a failure listener to kind of update the UI and tell the user what has happened as the dynamic module being installed completely, or has it failed, so that the user can take corrective actions as he requires. Now, one of the things I want to call out is that you have to manage the UI yourself. So how during the installation process, because this goes to a Play server, gets the module installed, it might take a few seconds. You might want to show a progress bar in that case, and for that you can actually use the install update listener. One other interesting thing to call out is that in case of large modules, which are 10 MB or more, a user confirmation is automatically thrown by the system. You cannot override this. And if you have like 5 modules that you want to install, and the sum of the size of these 5 modules during that one request, in one request, if you want to install 5 modules, and the sum of those, if they are more than 10 MB, then an automatic confirmation dialog will be shown to the user, and only upon confirmation from the user will it be installed. You can also set something called as deferred install, where it is downloaded and installed at a convenient time later. Assume that you have a game which has 10 levels. Level 1 to 5 is one module. Level 5 to 7 is another, and 7 to 10 is another module. Now, when the user reaches 4, you have a trigger that, hey, most probably he will need the second module. Then you can actually put a deferred install, so that when the device is connected to power and is idle, it will get it like an update and automatically get installed on the device. There's also one more thing that you can do, is to remove modules. So in case the user is running low on disk space, you can statistically look at what is the module that is least used. You have to track that information. But once you know that information from analytics, you can actually ask that module to be removed from devices where the usage is really low, thereby saving the size on disk. Well, and that's actually a very useful mechanism for keeping the size small. After installing, once the dynamic module, so I showed you the code for actually bringing the dynamic module onto the device and installing it. After install, for N+ devices, for Nougat and above, you don't need an app restart. But M and N, you need app restarts. Now, if you want to avoid that, there is a new library called a Split Compat library that we've added. And the setup is very similar to how you do a multi-dex library. If you worked with multi-dex before, the setup is quite similar. You change your application class to extend from a new class, and then the rest of the stuff is really straightforward for you to implement. And that you have to do in order to continue without restarting the app after installation. Now, in order to recapping, one of the things that you need to do is move to Google Play signing as a first step. Switch your upload format to app bundles. When you're building your app, create modules that are independent of each other, and get some user feedback to understand which modules are going to be less used, so that you can enable them to be dynamic features, and then enable dynamic features and serve them as dynamic features. So initially, when the app is installed, only the base module gets installed with basic functionality that everybody likes or uses. And then based on user preference, as user explores more portions of the app or newer features in the app, other features in the app, you can download those modules directly from Play Store. Now that's basically a nutshell of what is there in dynamic app module, and how dynamic delivery as well as app bundles. In I hope this session was really useful for you guys. You get an idea of what are the benefits of moving to app bundles, and how you can optimize, and how Play Store optimizes and serves these APKs to your user. This not only benefits you in same terms of saving time, and in creating new configurations and working with multi APK model and things like that, it also saves the user a lot of space on the disk. The user downloads are much shorter, which means apps, when from install to run, when the person clicks the install button to Play Store, the amount of data that gets downloaded reduces. There are multiple advantages for not only for you, also for your users. Hopefully this session was useful, and I'm hoping that most of you guys will try this format out during the hackathon and give us feedback on it. Thank you.